Hello, let's study this example together on latitude and longitude. This is taken from WAEC 2013 number 12. It's a theory question. The question says an aeroplane flies due north from a town T on the equator at a speed of 950 km per hour. So this is the speed for 4 hours to another town P. So I want us to interpret this question sentence by sentence so that we'll get it very well. There's a plane, yes, it flies due north from a town T, okay, on the equator. Okay, that means T is standing on the equator at a speed of 950 kilometers. Okay, so T is on the equator. A plane starts from there and move towards the north upward. Okay, question is clear like that. Okay, for this speed 950 kilometers per hour for 4 hours to another town P. Okay, so let's, with this speed that is given and this time 4 hours, let's get the distance between T and P. Let's start with that one first. So let's start with the distance. So first find the distance. Find the distance between T and P. Okay, so let's get this distance first. Alright. So let's find the distance between T and P. So how do you get that? You remember our formula for speed? Speed is equal to distance. Speed is equal to distance. So let's just put TP in bracket, distance TP divided by time. So this is the formula for speed. Speed is distance over time. So since the distance we need is T and P, which is TP. So let's put it like this. Then speed is given in the question. You can see it 950. So we say 950 is equal to distance, we don't know it, which is let's take TP as the distance, which is TP divided by 4. Then you can now cross multiply to get our distance. So therefore distance TP will give us what? It's going to be 4 times 950. And when you multiply 4 times 950, what will you get? So distance TP is going to give us okay, let's check it. 4 times 950 is 3,800. Let's put it in decimal to check it. That is 3,800 kilometer, because the speed is in kilometer per hour. So take note of that. Okay, so this is the distance from T to P. So this distance is going to assist us, because remember, all distance between 2 points, you need to get the angles between the 2 points. So let's move. For now, we don't know the angle of T yet. We don't know the angle of P, but we have known the distance between T and P. So that one is settled. Let's move on. It then flies eastward to town Q on latitude 65 degrees east. Okay, from point P now, the plane now flew to eastward direction to another town Q. So town Q have a latitude of 65 degrees east. Let me check something here. It then flies eastward to town Q on, okay, sorry, this is longitude. It cannot be latitude. The longitude is east and west. So let's correct this place. This is longitude. This is longitude. Longitude. Found that we have corrected this place. Let's start from here now. It then flies eastward to town Q on longitude 65 degrees east. Okay. If the longitude of T is 15 degrees east, okay, you can see now longitude of T is given now on the equator, 15 degrees east, so we can move that way now. So the question is complete. Now represent this information in a diagram. Okay, I want to interpret this question using this my three-dimensional view to illustrate it. This is our three-dimensional view. You can see it. So this is a sphere. You can see our north and our south. Then this is the equator, this line. This line is the equator. Then this is the Greenwich meridian from north to south. So, and both of them serve as the reference line. So 0 degree is on this place. Okay, let's see now. The question says this plane. Okay, let me start from the beginning. It says an aeroplane flies due north from a town T. So T is what? T is 15 degrees east. So this is longitude, 15 degrees east. So that means T should be somewhere here. You know, this is how it is. East is this side, west is this. So 15 degrees east should be somewhere here. So let's put 15 degrees east. Let's put a point there. Let's interpret it with this three-dimensional before we go to the plane shape calculation. Okay, so from the center to this point, this is what we are going to get. And the question call it point T. Let me change it to point T. So this is point T. Okay, so that is it. Then if you introduce the angle, so the angle between these 2 points is so I want it as a value, not okay. So this is the angle. I think you can see it clearly. So it's like this. So this is T. If T is 0 degrees, you can see 0 degrees. So it moves towards east. So it will go like this. That is it. So this is east. Well, at which angle? Let me check. The angle is 15 degrees east. Okay. So it's 15 degrees east. So we leave it at 15, 19, 18, 17. Okay, 15 degrees east. So that is it. So let's label it there. So this is the angle towards east. Okay, so we are in order now. Let's keep interpreting the other place. So that is where the plane started from. It flies due north from a town T. So from that point T, it moved up. And T is on the equator. So we have put it on the equator. It now flew up to another town P, which we have calculated the distance. So that one is settled. Okay, so let's locate town P. But before we locate town P, let's see. Oh, it's part of what they want us to calculate. You can see it. Latitude of P. I wanted to ask, let me know the latitude of P, so we don't know it. So they want us to calculate latitude of P. But the most important thing is the plane started from T and moved northward. You can see it flew due north from T. That means this is point T. If I put my longitude line so that we can see it well. So our longitude is this. Okay. So this is our longitude. You can see the line. So the plane started from here. Let me introduce a point. Started from here and move up. And that point is point P. Let me change the name to point P. Okay. So you can see it. So it's just like this. Okay, and the name did not change. Let me rename it again. Okay. Point P. Okay, so point P. So point P, you can see it. It rises up. You can see it towards the north. So it started from T. This is where the plane is. It now move up to another point P towards the north. See this towards the north. So somewhere. So let me put latitude on it. But the question wants us to find the latitude. So let me just put a latitude. Something like this. You can see this is the latitude. Then this latitude, we don't know the angle of this latitude. so which is from the center of the earth to this place. We don't know the latitude, so that is it. Then okay, we know that now, so let's just leave it somewhere here. I want you to understand the question, that's why I'm doing it like this. So a plane starts from T, move up north to a point P. You can see it, point P. Okay, then from there it then flies eastward to town Q on longitude 65 degrees. See, it then moves eastward. So from here, let me place another point again, which is called point Q. If you are getting it the way I'm doing it, I'm using this solid shape so that you can understand it very well. This point Q. Okay, so the plane is now here. After starting from T, it flew to another point P. From here, it now moved to another point Q towards east. Remember, this is our reference line. Don't forget, this is our reference line, and this is east, 15 degrees east. It flew due north to P. From north, it flew again, 65 east. So let me put that angle. Let me put the angle so that we can see it very well. So let me put this point here. Okay, I want you to get it very well. Okay, I have this now. I have my, okay, so if I put my line there, this to this, you can see it. Okay. So you see, so you can see the mark. Let me hide B and C. I don't need them. Let's hide them. Alright. So this T, 0 to T is 15, is also the same thing as 0 to P. So both of them, P and T, they are both 15 degrees to east. But it's only the latitude we don't know for P. Then Q now, this Q, you can see it from P, it moved towards east at 65 degrees. So let's put the angle. So I need to draw the line that connected first. Okay, so the angle that is given is this. Okay, this is 56. The angle is 65. Okay, I need a value, not. Okay, you can see, so this angle from this point, you can see P is 15, so it moved down to 65 degrees. Okay, so that is it. So let me put the longitude line. Okay, so this is the line of longitude. Okay, so you can see it clearly now. Okay, let me hide this. So you can see it, 65 degrees. So this is the longitude of Q. So this is the movement of the plane. I want you to see it as a solid shape so that it will be easier for you to understand. From equator, 15 degrees east, you can see it, 15 degrees east. This plane starts from point C. See the point C, it flew due north to P. Latitude is not given, we'll calculate that later. Then from P, it flew east, see, towards the right hand side, 65 degrees. You can see the 65 degrees. You can see it there, 65 degrees. You can see the question is okay and it's clear. This is very understandable. So let's see what they want. They said represent this information in a diagram. See, so this is the diagram. This is how the diagram look like. but you know you cannot put this one on your paper, this three-dimensional view. So what you will put down on your paper is something like this. So this is what you will submit, because your paper is a two-dimensional plane. So you get your circle, put your circle there, you label your center, then you get your ruler to locate your latitude and your longitude. Okay, you put it at the middle, you draw your line. Okay, draw your vertical line. Okay, very nice. Then you now label your north, your south, your east, then your west. Then these two lines represent the reference line. Then they started with a point 15 degrees, which is the starting point, point C. So you can see it, you put it down like this on the equator. So if I'm taking this as my equator, so I can call this point T. If I'm taking this as my equator, so this point T. Okay, then make sure you label it. It says 15 degrees. This is what you draw as a solution. 15 degrees east. Very, very important. Then it then flew upward to a point P. So just go up and put something like this, because you don't know this latitude. So this is point P. Just label it. It's also at 15 degrees east, but you don't know the latitude of coming up to north. But make sure you label it. This one we don't know it. Just call it, you know, we usually use alpha. Just call it alpha. Alpha degree, that is the angle towards north. You know, we usually use alpha as latitude, so just call it alpha. Then from here it moves again to a point. That point is point Q, and it's towards east. So you go around again, something like this. You go around. When you put something like this down on your paper, just make it neat with good pencil sketch. Your examiner will know that you know what you are doing. See, this is your point Q. Then you mark it. Make sure you label it. Let me label it on this side since up is tight. So this is 65 degrees. Let me write it well. This is 65 degrees. 65 degrees east. So when you have this kind of sketch, nobody will say you don't know what you are doing. This is very neat and fine. Just label it well so that your examiner will know what you are using. Remember, I labeled the latitude of P as alpha, because this is what we are going to calculate next. So this A part of the question, you have sketched it, so you have answered A. So after doing this, you now go and finish up your solution. Let's go and complete our work. So A is settled. You have the diagram on your paper there. Then let's see the B part now. So the B part. Okay, the B part says calculate the number one, that is BI. The BI. Okay, latitude of P. So this is what they want us to calculate. Then how do you get latitude of P? In order to calculate latitude of P, you need to know the distance between T to P. Remember, distance between P to T. So if you can get the distance between P to T, you are okay. And you remember we calculate our distance. Let me show us on the diagram again. So distance T to P. So you can see distance T to P, they are standing on a great circle. You see, so we are going to use capital R as our radius. Then it is the angle between them that we need now, that is the alpha. Alpha is the angle between T and P, because equator is 0 degrees. If you view it with this 3 dimension, you get it very well. You can see it. The angle between T and P, you see, that is the alpha, that is the latitude, because T is already at the equator. See, T is already standing at the equator. So from 0 degrees down to this angle. So we don't know this angle. If we can get this angle, that will be the latitude of P. Very simple question. It's not difficult. So, and it's on the great circle. And since it's on the great circle, and the distance is already known, which is TP. So we are not doing any other thing. So just put your TP. TP is equals to your theta now will now be the alpha. Theta is the alpha we are looking for now, which is alpha over 360 times 2 pi times 2 pi. Then use your capital R. That is it. So this is the formula we are going to use to calculate our angle between, that is the latitude of P, which is angle between T and P. So with this, we are through with our solution. Just substitute values and you are okay. Okay, so TP is already calculated. We have 3,800. 3,800 is equals to alpha, we don't know it, divided by 360 times 2 times pi is given as 22 over 7, then times R, which is 6,400. So that is it. Let me move them to this side. Okay. Okay, let me shift them to this side. Okay. Alright. Okay, so what next? At the end, we need to make alpha the subject of the formula. So let me make it fast. Let's simplify this side. 2 times 22 times 6,400 divided by 7. Let me use my calculator and do it fast. 2 times 22 times 6,400 divided by 7 to give us that. Let me put it in decimal. Okay, so the numerator is this side now. Okay, then which is equals to 3,800. Okay, so we have 3,800 is equals to alpha. Okay, alpha divided by 360 times this answer we have now, which is 40,228.571. Okay, so now that we have this, what's next now? Okay, what next? We can now, okay, we can divide. Okay, let's cross multiply with this 3,800 times 360. Then we'll now divide both sides by this. So this is just a simple equation. So our final answer for alpha will now be equals to, okay, now be equals to 3,800 times 360, then divided by 40,228.571. So this will give us our angle. Okay, so final answer of alpha is now, okay, let's simplify this. Let me do it here also. You have 3,800 times 360. You can use your calculator and check all this. That's what I'm doing. Use your calculator and check the result. You see that the answers will be the same, 8.571. So the answer is 34. So 34.006. So it's degree because it's angle. So that is the answer for alpha. Let's see what the answer. Okay, correct to the nearest degree. So we take it to whole number. Let me move it up. So nearest degree, let me go up a little. Okay, to nearest degree, our answer will now be alpha is equals to 34 degrees. So this is the answer for the latitude. So that is the first solution to this question. So take note of this. Let me move it down to have space. So that is the first answer. So calculate the latitude of P correct to the nearest degree. So the latitude of P is 34 degrees. You see all what we did? First of all, get your distance using the speed and the time. You get your distance. Then since we know distance of TP, and we know the angle between T and P is the alpha, that is the latitude itself. You saw it from the diagram, then which is theta over 360 times 2 pi r. Because both of them they are standing on great circle, that's why we use capital letter R. So that is all with that. Then the second part of the question now said we should calculate distance between P and Q correct to 4 significant figures. So distance PQ. So that's what we need to do now. Okay, which is number 2 now. This number 2, distance PQ. Let's look at the diagram again so that we know where PQ are standing. Okay, P and Q. You can see both of them are standing on the small circle. So we are going to use small letter r as our radius. But we need to know the angle between P and Q. So P is already standing at 15 degrees. You can see it, 15 degrees. While Q is already standing at 65 degrees. So therefore the angle between P and Q will be 65 minus 15. In case you want to view it well in 3 dimensions, you can see it here. You can see it. The angle from 0 to Q is 65. The angle from 0 to P is 15. So which is the same thing as this angle T and P. They are standing on the same line of longitude. So all you just need to do is to use 65 minus 15 to give you the remaining angle. So that is what we need first. So the angle. So angle between P and Q. So angle between P and Q. Angle between P and Q will give us what now? Okay, let's move it a little. Let me rise up so that we can view it very well. So angle between P and Q. Okay, it's going to be theta. Okay, I need mathematical operation. It's going to be theta equals to 65 minus 15. That is the two angles. 65 minus 15 will give us the angle between them. Take note of that. So 65 minus 15 will give us what? This one should not take our time. This one should be 50. This one is 50 degrees. Okay, so that is that. So now that we know the angle, the next thing to calculate is the radius. And remember, radius is, the small r is r cos alpha. That's how we do it, r cos alpha. And alpha is the latitude of the point where both, latitude of the angle of the 2 points, where the 2 points are standing. That is, alpha is the latitude of this line where the P and the Q they are standing on. So we have calculated that latitude as 34 in the other session, which is 34 degrees, but we are going to use this for decimal places. Alright, so R is equals to 6,400 times cos 34.006. Then R is equals to, let's use our calculator to do this. Okay, if we use our calculator to do this, okay, let me use my calculator here. So we have 6,400 times cos 34.006. So the answer is 5,305, 5305, 5305, 5305 5305.4657. Okay, let's take 4 decimal. 4657. 4657. 4657 kilometer. Okay, so this is the radius. Now that the radius is known, the work is over now. We now use our distance, which the question says we should calculate. Distance will now be equals to, let's use capital D as the distance, will now be theta over 360. So theta is 50. 50 divided by 360 times 2 times 22 over 7 times, the radius is now 5305.4657. Okay, so as you get final answer of D will now be equals to, let me do it in this place, will now be 50 divided by 360. You can use your calculator and do the multiplication, you will get the same result. 22 over 7 times 5305.4657, which is okay, let me put it in decimal. Okay, so D is equal to 4631.756 kilometer. And since the question says we should leave our answer to nearest to 4 significant figure, so D will now be equals to, you just count 1, 2, 3, 4. You approximate 7 is more than 5. You add 1, which is 4,632 kilometer. So this is the final answer. So take note of this. So this solution of the question, why this alpha we calculated the other time, you know it's towards north. Don't forget to put your 34-degree north. Even in this one also, 34-degree north. So remember when I sketched it, you saw it alpha degree north. You need to put it. It's very, very important. So this is the final answer to this question. WAEC 2013 number 12 theory. Take note of this. Follow the step, follow all the instructions, and you see that they are simple. Thank you.